Hello. Yes. So welcome you all. Good evening. Welcome to today's webinar session. So the objective of today's webinar session is BMS and BTMS and the importance of the BTMS and BMS in a battery pack, as well as we go through the basic of the battery information so that we easily understand the BMS and BTMS. So let me start. Some participants are joining. We started now. So before the starting, we need to understand the hello. Yes. So before the starting, we need to understand the electric vehicle structure. As shown figure, you can see the battery pack is installed in floor of the electric vehicle, as well as the charging port. Thereafter, the electric motor, which is located in front of the vehicle, and the orange color cables flowing through the motor, battery, and the charging port, which is in a high voltage cables. So this is a basic structure of electric vehicle. Things all electric EV does not good for the life cycle of the battery. That's the reason they cannot discharge whole battery at the one time. Thereafter, over temperature cutoff system. So this system, BMS has having transistors to sense the battery temperature, and it's cut off the battery when it senses the maximum temperature has been achieved. That means when the temperature sensor is sense the maximum temperature of this battery pack, then it's cut off the systems. BMS enforce the maximum temperature the battery can achieve during the charging and discharging time. That means at the time of charging and discharging, if the battery perform maximum temperature, then it's cut off the all systems. That means the operating temperature of the lithium cells affect their life cycles. That's the reason we use the thermistors for the sensing temperature in the battery pack. Having two thermistors which we are using in battery pack, first in a battery pack and second with the BMS. Then continuous current, as we know in a battery management system, having a series connection and a parallel connection, so that we use continuous current system that check the ensure that this ensure the BMS is functioning smoothly in all aspects when the operated at the particular charge and discharge current. At the time of charging and at the time of discharging, BMS is performing smoothly with the all aspects. That's the reason we use the continuous current system in a BMS. Now we learn about the software or smart BMS. Software BMS, or we can call it as a smart BMS. So what is a smart BMS? So basically it has all feature of the hardware BMS. It have all the features of the hardware BMS, but additionally can collect the data, can have memory to store the data and transmit the data via CAN communication, Bluetooth communication, and etc. That means we can communicate with this BMS with the help of Bluetooth or CAN communication. What is the CAN and Bluetooth communication? We learn in next. Before that, we check the advanced functionality of the software BMS or smart BMS, which is SOC, state of charge, DOD, depth of discharge, then SOH, the state of health, communication interference, cell monitoring, diagnosis, cell balancing, and temperature measurement. This is a advanced functionality which is performed by the smart BMS, and we can communicate or we can check or we can analyze those data with the help of communication systems. So this is in a smart BMS. In a smart BMS, having some additional functionality like SOC, as shown figure, 0% battery, 25% battery, 50% battery, 100% battery. So what's that? So this is a state of charge. It is the indicate of the energy stored in a battery, right? So it is important factor to understand to user because it's notified to remaining capacity of the battery and rectify the performance of the battery pack. That's the reason SOC is used in a battery smart BMS. So this is a state of charge SOC, right? Then depth of discharge, it is DOD. As we can see in image, 100% SOC and 0% DOD, 20% SOC and 80% DOD. That means the depth of discharge is defined as capacity discharged from the battery divided by the battery nominal capacity. That means you cannot discharge the battery after the DOD is reached, right? So DOD percentage is 8%, 80 to 85%. We cannot discharge battery after the DOD is reached. Then you need to charge the battery again. That means you completed your one life cycle. Now the data logging and reporting. As shown figure, you can see the graph, then the various data over there. We can transmit that data with the help of Excel. We can export that data in Excel. So recording historical data about the battery performance, even and coordinate which can be used analysis and maintenance. We can maintain that data or we can store that data and we can analyze that data. Sorry, just a moment. I'll share the presentation again. I think someone is sharing.
Yes, now it's visible.
Now visible now? Okay. Okay, so data logging and reporting, recording the historical data about the battery performance. We can use that data for the purpose, for the maintaining purpose, like as you can show in figure by the graphs, by the various load conditions data as shown in figure. So those data we can use for the maintenance purpose. We can analyze those data for the battery maintenance. Thereafter, the cell balancing. The cell balancing is most important part in a BMS, in a battery pack, because each cell performing well or not, which is ensured by the BMS. The BMS ensure that individual cell with the battery pack are charging and discharging evenly to maintain the optimal performance and prolong battery life. That means at the time of charging and the discharging, each cell or each whole battery pack are performing well or not, or discharging or not discharging, which is monitored by the cell balancing. So this is an work of the smart BMS. Now the type of communication systems, like we are using some communication system to interference with the battery BMS. A battery management system BMS and electro system managed to recharge and the battery cells, the battery pack, facilitating and the safe uses a long life of the battery with the help of communication system, which we are using three communication system. First is Bluetooth communication. Next is IoT, the Internet of Things, cloud connectivity system. And the third is CAN communication, which is a controlled area network. As you can see the above figure, which is a battery package showing, and the BMS, which is we can communicate with the help of the these three systems. If we talk about the Bluetooth communication system, UART stand for the Universal Synchronous Receiver Transmitter, and its work with the Bluetooth interference. As shown in figure, having one application, Bluetooth application, which is showing the SOC. As we learn about the SOC, which is a state of the charge of the battery, that means the remaining capacity of your battery. Thereafter, 13.8 volt is remaining voltage, 15 ampere. Then the 25% is temperature, 25. Yeah. So 25%. Hello. Please mute your mic. Yeah, so this is an application which send the data to the end user and their cell phone application. As we saw the data battery in user cell phone in the smart BMS. So this is in a Bluetooth communication system. Now the second is IoT, the Internet of Things. The cloud battery communication system combined with IoT and cloud computing technology with the advancement in a BMS software designed for the remoting and the notification system. IoT is used to notify the manufacturer and users to about the real-time battery pack status or the battery data. As showing in figure, the vehicle are moving on a road and having some battery packs with this vehicle, which is connected with the IoT, which is a Internet of Things cloud connectivity system, and is required a wireless internet and can transmit the data to the cloud, and it can be viewed remotely anybody with the access. You can access the those vehicle data, battery pack data with the remote location, and you analyze those data with the help of IoT. So these systems are not widely used or used in India. Actually, it's not. This system is not in use in India nowadays. The basically Bluetooth system and CAN communication system are widely used in India in electric vehicle. This is a CAN communication system controlled area network. As shown in figure, it is robust vehicle bus stand that allows the microcontrollers and the device to communicate with each other. They're having some microcontrollers and devices to communicate with each other. If you want to connect the host computer, then there is an option to communicate. We can monitor the data of the BMS or battery pack with the help of host computer, right? So there is an option to connect with the vehicle, and we can monitor that data with the help of host computer. It has also been implemented for the communication between battery charger and the battery management system, right? So the charger is also communicate with the BMS in a level 2 and level 3 charger. So why do electric vehicle catch fire? As you can see, when it is the heat from the EV batteries mixed with oil that has leaked, the battery burst into the flame, right? That having some maintenance issues or shock circuit issues, rat bite issues. So those kind of issues comes for the fire catchings. Thereafter, the additionally since Indian temperatures is typically hot, as we all know, in India the temperature and weather is very hot. This fire occurrence happen frequently. So preventing of overheating of the electric vehicle battery is smart technique to addressing this issue. So that reason we use good quality battery cells, smart battery charger, time to time maintenance, smart BMS, BTMS, and etc. Right? So this is an BTMS. This is an BMS. Now we learn about the BTMS. What is a BTMS? For preventing those kind of issues. So what is a BTMS? BTMS is a battery thermal management system. A battery thermal management system controls the operating temperature of the battery by entering the dissipating the heat when it's too hot when it's too hot or preventing when it's too cold. When the temperature is going up, then the BTMS is work and hold the temperature of the battery pack, or when the temperature is going cold, then the heat with the help of heating the battery pack going to be reach up to the abnormal temperature of the battery pack. So the engineer used active and passive and hybrid heat transfer solution to modulate the battery temperature in this system. So there are three systems are using in electric vehicle, which is the active, passive, and hybrid. So basically, active is widely used in India, an electric vehicle, which we learn. So these three types. First is active, second is a passive, and hybrid. So active material, in active material, air and the liquid is used. Passive, the PCM and heat pipes are used. The hybrid PCM plus air, PCM plus liquid, and PCM plus heat pipes are used, mainly used, right? So the main aim of the BTMS is regulate the temperature of the cell of the battery and thereby increase the lifespan of the battery, right? So main work of the BTMS is regulate the battery temperature as per the atmosphere or as set it with the BMS and regulate that temperature to increase the lifespan of the battery. So this is the basic work of the battery management, battery thermal management system. So active air cooling system as shown in figure having one a battery pack and the air blow system which blow the air inside the battery pack and transmit the heat through the air and through the outside of the battery pack. So this is one kind of cooling system which is active BTMS is based on liquid or forced air that use energy using equipments like pump, compressor, fan to push the coolant flow through the battery module. So this is an air cooling system in a BTMS. Now we learn about the liquid cooling system. The liquid cooling system, as you showing figure, the vehicle having radiator, liquid cool store area, and the liquid flowing tubes. So basically, this liquid flowing through the tubes or plates around the battery cells, carrying the heat to the different place like vehicle radiator, and the same process happen when a car or vehicle is moved, right? So what happened exactly here? The radiator cold that liquid and sent to the liquid flowing tubes through the battery pack, and same process happen again and again. That hot liquid is comes under the radiator and again heat throwing through the liquid flowing tubes. So these processes continuously happen again and again. So the liquid cooling is widely used method to keep the electric vehicle batteries cool, right? So this method is used for the cooling the electric vehicle battery pack. Now the phase changing material PCM. So what is the PCM? PCM is absorb the release the thermal energy, absorb and release the thermal energy, and during the phase transactions such as melting and salt flowing. As you showing figure, the having PCM material as well as the cell separators and cells. This material can effectively manage the temperature speaking, but are obtained using the combination with the other cooling methods to enhance overall thermal performance, right? So these type of systems are not currently implemented in electric vehicle. They having recently become a significant due to their operational advantages. Also, it's very high cost materials which are using, but now in electric vehicle, those systems are not used. Also, the hybrid system combine multiple cooling methods such as PCM with forced air or PCM with liquid coolant. So hybrid system leverage the strength of the different techniques to achieve those superior thermal management. So those two systems are not widely used in electric vehicle. So basically the liquid cooling and air cooling systems are widely used in India. Now we learn about the battery pack assembly. The create a lithium pack battery pack with a smart BMS involving the several steps, right? So hence general overview of this process is first is identify the required size, voltage and capacity as per your application, right? Identify the size of the battery as per your application voltage and capacity, right? Then choose the type of lithium cells. You need to choose the type of cells, like you need to choose the chemistry, lithium ion or lithium ion paraphosphate, right? Then ensure that all cells having the same voltage before the assembly. You need to ensure, you need to check the each cell having the same voltage, right? If you took the lithium ion cells, then lithium ion cells having 3.7 volt, then each cell having the same voltage capacity. Then arrange the cells in a desired configuration, series and parallel. Like if you add in series connection as per your application, then in a series connection you added a voltage, right? If you add a 12 volt cell, if an example, if you add in a 12 volt cell, then the voltage will be increased, and you add a parallel, then ampere will be increased. So after that, the spot welding and nickel strip to connect the cells ensure the proper connection for the both series and parallel configuration. With the help of welding, which is a spot welding, with the help of nickel strip, you need to connect the battery pack with series and parallel connections. Thereafter, use the insulation material to prevent the short circuit between the cells and connections. Same, the select a BMS that the match that the volt current specification of your battery pack has been required as 4S, thereafter the 8S, 13S, this kind of series you need to connect BMS with your battery pack as per the requirement as per the battery pack. So connect the main positive and negative wire to the pack terminals, as well as the connect the balance wire to each cell group. This allow the BMS to monitor the balance each cell. Along with that, place the temperature sensor in a battery pack to monitor the cell temperature, right? Then external connections that connect for the charging and discharging. You need to connect a port to charging and discharging. Then enclose the pack, place the battery pack and the BMS in a proactive enclose. Then they test the battery pack for the correct voltage and ensure there are no shorts, right? Then the test pack under the load conditions to ensure the performance as expected. You need to check the battery pack with the various load conditions that ensure the performance as expected, right? So this is an overview of the process of smart BMS with the lithium ion battery pack and a smart BMS involving the server. So hence a general overview of this process. So this is a battery pack. So this is all from my side about the basic information of the battery as well as BMS and BTMS. Also, we learn about the basic process of the battery pack assembly with the smart BMS. आप किसी को भी कोई क्वेश्चन और कुछ क्वेरी रहेगी तो आप आपका माइक ऑन करके आप बात कर सकते हो, या फिर आपका क्वेश्चन चैट बॉक्स में आप ड्रॉप कर सकते हो.
Good evening, sir.
Good evening, ma'am.
Sir, I have already written message, but still I want this complete video on our email ID, sir. As I am PhD student, so my research area is also electrical vehicle, so I need this information, sir.
Okay, not an issue. We'll share.
Because earlier when there was such a seminar or was there on electrical vehicles for different parts, that same video was also we don't get on our email id.
Okay, not an issue. You just drop your email address. We'll share.
Okay, thank you, sir.
Okay, thank you. Anyone else? Okay, we'll share.
Sir, am I audible?
Yeah, you're audible now.
Good evening, sir. Actually, I have a doubt regarding the scope of battery management in India. With respect to other countries, we see there's a lot of scope. But for India, like if we have, like if we are gonna pursue this in our MS or PhD, will there be any scope for it, sir? Like for the next 10 years?
Yeah, having some scopes, but nowadays the electric vehicles are slowly growing. So it will take some time to for growing this industry.
Okay, sir. Thank you.
Hello.
Yes.
Yeah, do you conduct any hands-on session or any experimentation like that in battery testing and management, BMS like that, or be thermal management system like that? Anything experimental or something simulations, hands-on? Is there anything, any course like that?
You can visit on our website. I'll drop the website in a chat box, so you will get the those information in our website. Okay.
Yeah, I have gone through, but there is no hands-on like that. I mean, there is no lab or something like that. Physical lab. It is only recorded videos. They are saying.
Okay. You just drop your email address, so I'll share the those information.
Okay. Yeah.
Anyone have a doubt about this session? You can ask in Hindi also, or you can drop the question or query in a chat box. one, I got one question in chat box, which is the life cycle of the electric three-wheeler battery. So basically, in electric three-wheeler, there is a two types of three-wheeler. There is a L3 category and L5 category. So in electric three-wheeler, L3 category having a lead acid battery, and L4 category, which is a lead acid as well as the lithium-ion batteries are used. So in a lead acid battery having 500 to 800 life of cycle, and if in a L5 category, if they use the lithium and ferrophosphate batteries, then the life cycle is 2500 to 3000, and lithium and for the lithium and battery 1500 to 2000 life of cycle. In a three-wheeler, do we use the BMS system? As I said about the three-wheeler, if we are using a lithium-ion battery, then we using a BMS, or we are not using a lithium battery, or we are using a lead-acid battery, then we cannot use the BMS system. Anyone else? Yes, anyone? Can we cars are more effective than petrol diesel cars? Yes, cars are more effective than the petrol and diesel car as we compare with the petrol and diesel engine. They're having a very uh, high maintenance. Then they're having a very high moving parts, wear and tear parts. So that's having very high maintenance. And in an electric vehicle, they don't have that kind of maintenance. So yes, the electric vehicles are more effective than petrol and diesel cars. Also, they environmental freely.
Thanks, sir, for hosting the webinar. Your expertise and insight were invaluable for our learners. I would like to take the opportunity to introduce our company, ISI India product and services that we offer in EV technology with a small video. So kindly have a look on video.
Yeah. As we are living in the fast changing world of electric vehicles, ISA India is leading a tech organization, paving the way for innovation and revolutionizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, e-bike design challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youths for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQF courses aligned with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero Motocorp, with Government of Kerala in partnership with MG Motors at two locations, IIT Mandi, private universities like SNMU, Calcutta's University, Sharda Universities, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus centers of excellence worldwide. With India rapidly moving toward an electric only future, ISA India is well positioned to develop a workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks for watching the video patiently. So don't miss out on this opportunity to discover the endless possibilities of EV. So any of you want to enroll in this course, kindly send us inquiry through our QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Thank you.
If you have any inquiry about our courses, you can scan this QR code and our executive will contact you shortly.